Truth table. Truth table for a given statement will show the resulting truth values for the various combination of truth values for the variables. Using this truth table, you can show the validity of any statement. So for example, let A be the statement formula of this statement. Now we create the truth values for the statement P and Q first. For P, the truth values are true, true, false, false, and for statement Q, true, false, true, false. Using this combination, we can find the result for P or Q. For P or Q, if either one of these gives true, then the result is true. Then we get the answer for the P or Q is this one. Then we tackle the problem with negation. So the negation, we just reverse from true to false, from false to true. Next, we find the truth values for Q and P. So for Q and P, if both give true, then the answer is true. Otherwise, false. Then we compare between this column with that column. If false, then true, then give true. If false, then false, then give true. If false, then false, also true. But for if true, then false, then becomes false. So you get the answer. So make sure you know how to do the truth table in order to show the validity of any statement. From single statement to multiple statement, make sure you do the correct combination of truth values. Tautology and contradiction. Tautology is the statement for always true. So statement formula A is said to be a tautology if the truth value of A is true for any assignment of the truth values true and false for the others. And then for contradiction is for always false. A statement formula A is said to be a contradiction if the truth value of A is false for any assignment of the truth values are true and true to the remaining. Logically implies and logically equivalent. Logically implies has this notation: if A then B then equals to true. So a statement formula A is said to be logically imply a statement B if the statement formula if A then B is a tautology. So we use this notation to prove if A then B is a tautology. Logically equivalent has this notation: A if and only if B equals to true. A statement formula A is said to be logically equivalent to a statement formula B if the statement formula A if and only if B is a tautology. So you can also write the logically equivalent like this or like this. Now let us see this example 2 on how to use the truth table to show two statements are equivalent to each other. So we have if P then Q and not P or Q. So first we set up the truth value for P and Q: true, true, false, false, true, false, true, false. To find the truth values for if P then Q, you can label this as statement A. So the result for if P then Q as follows: if true then true, then the result is true. If true then false, then the result is false. If false then true, then it becomes true. If false then false, then it becomes true. Then for the next one, since we have negation P, then you find out the truth value for negation P as follows. We just reverse the truth values for P becomes not P. And then we find out this one, which we can label as statement B as follows. To find the truth values for statement B, we compare the truth values of not P and Q. So if we consider not P or Q, if either one of these is true, then the result is true. Otherwise, give false. So true, false, true, false, 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 true, 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 false, true, true. So if we have both statements A and B have the same truth values, then you can say that A equivalent to B. Properties of logical operators. To show the logic of any statement or to show the validity of any argument, we need to use several laws as follows: commutative laws, associative laws, distributive laws, absorption laws, idempotent laws, double negation law, and De Morgan's laws. So make sure you memorize all these laws and know how to apply it in solving problem. So let me show you the example on how to utilize the laws just now. So we have example 3. Show that this statement is a tautology without using truth tables. If we have this line without using truth tables, then we need to use the laws to prove it. To solve this example 3, we copy the statement first. And then if we notice there's an arrow in the middle of two brackets, which stands for if this one then this one, then we have to change the if then statement into disjunction as follows. So the formula is if A then B equivalent to not A or B. So you have to convert from this one to this one. Then you have this statement. Then if we have a negation outside of negation P and Q, that means you can use the De Morgan's law, which this one, then to get this line. Meaning that the negation, you times it in, and then you convert the conjunction symbol into disjunction based on the De Morgan's law. And then the double negation, you'll get the original P, and then we solve another arrow using the same method into not Q or P becomes this one, and then we solve another negation outside bracket using De Morgan's law to get this one, and apply double negation to convert the double negation of Q into Q, so you get this line. And then for this one, you can use associative law to put another bracket that cover from this side to that side like this, and then you can use the distributive laws to solve the not Q or bracket Q and not P becomes this one, so this one becomes true. And then we have this one, and since the true and not Q or not P is similar to not Q or not P, then you get this one. And then for P, you can put together with the not P by using the associative law like this, and then for P or not P, you get true, and eventually you get tautology. So this is the example 3. Actually there's a simpler version to solve this problem. So if you have any question, you can ask me during the online session. Thank you.